Hey students, so in this video we shall be discussing the solution of IFoA September 2020 CS1 paper A. We got a lot of appreciation for the past two videos which we had released day before yesterday and yesterday. We have also got certain suggestions which we would try to incorporate in this video as well as the coming videos. So one of the suggestions was that most of you were looking for the final numerical answers to the questions and not the complete questions. So in this video, unless required in certain questions where I have given the detailed solution, in most of the other questions, I have simply given the numerical answer. It took me around 78 minutes to solve this paper, not on MS Word, on paper itself. The few of my students who were well prepared, they were able to complete the paper, typing it on MS Word within 2.5 hours only. Among the papers, CM1 paper A, CS1 paper A, CS2 paper A, CM2 paper A, CS1 paper A was one of the easiest. Even if you would compare it to previous settings, this paper was definitely a very easy and a direct one, both in terms of the difficulty of questions asked and also in terms of the lengthiness of the paper. So I didn't get much time to double check my answers. So these are the answers which I got in my first attempt. In case there is any discrepancy with the answer or you feel that any one of it might be wrong, feel free to inform us regarding it through the YouTube's comment section. We'll try to rectify the same and inform the students appropriately. So the first question, again a very direct one. We have been given x1, x2, x81 to be IID random variables, continuous random variables, each of them having a mean of 5 and a variance of 4. So the first part asked us to determine the sampling distribution of the statistic t, where t is nothing but summation xi. So this is a direct result of CLT. T approximately follows normal 81 into 5, 81 into 4. So the mean comes out to be 405 and the variance comes out to be 324. Part 2 was to calculate the probability that t is greater than 369 using my part 1 result. So we need probability t greater than 369. So then I standardize, I have skipped a step here. Probability z greater than 369 minus 405 divided by root 324. This comes out to be probability z greater than minus 36 by 18, which is probability z greater than minus 2. So we know the properties of standard normal distribution. Those are symmetrically distributed about the point 0. So this would come out to be probability z less than 2. That is nothing but phi 2. And we have this value directly from the tables. So this was a pretty straightforward question. While I was solving this, in the first go, a mistake which I committed was I just took it 324. I forgot to take the root of it. So it might happen that many of you might have skipped this thing. So otherwise this was a pretty direct question. 4 marks, pretty direct and easy to get. Next question, part 2. This is in fact one of those questions which even students from class 12 would have been able to attempt with no prior knowledge of CS1 as such. A pretty easy question based on the rolling of a die. So a pair of fair 6-sided die is rolled once. It is equivalent to rolling a single die twice. Okay. So we need to identify which one of the following option gives the probability that the sum of the two dice is 7. So how can we get a 7? It could either be the combination of 1, 6, 2, 5, 4, 3. When I say 1, 6, it could be 1, 6 or 6, 1, 2, 5, 5, 2, 3, 4, 4, 3. So we have 6 ways. Total combinations are 36. So my solution is nothing but 1 by 6. So question 2, part 1, A2 is 1 by 6. The next part was to identify the probability that at least one die shows 3. So this probability is nothing but 1 minus probability that both the dice shows 3. So there is only one way in which both of them show 3, and it would have a probability of 1 by 36. So my required answer would be, 1 minus probability that none of them show 3. So the probability of not getting a 3 in both the roles would be 5 by 6 into 5 by 6, which comes out to be 25 by 36. So the required answer would be 1 minus 25 by 36, which is 11 by 36. So part 2 A3, 11 by 36. A pretty direct question again. Third part, identify which one of the following option gives the probability that at least one dice shows an odd number. This again would be 1 minus probability both of them show even number. So this comes out to be 1 minus 1 by 4, which is nothing but 3 by 4. So option A2 here, 3 by 4. Next question. So first three questions were pretty easy. The first three parts of this question were pretty easy. Few of the students struggled in part 4A. So the random variables representing the numbers on the first and second dice are denoted by X and Y respectively. Note that nothing is mentioned. So the throw which we get in a die is definitely independent of what we get in the other die. So X and Y is independent, and this particular property or assumption which we're taking, which is very intuitive in nature, shall be required in the later parts of part 4. So part A is identify which one of the following option gives the correct expression of expectation X plus Y given X equal to 4. So if X is given to be 4, so this basically reduces to what? Expectation 4 plus Y given X equal to 4. Now I'm assuming X and Y to be independent. So I would basically get, if X and Y are independent, then expectation Y given X is nothing but expectation Y. So I would be basically left with 4 plus expectation Y. State a necessary assumption for deriving the answers in part 4A. I assumed X and Y to be independent. Part C is to determine this value. So Y is nothing but the number which we get on the throw of a die. So its expectation would be nothing but 1 into 1 by 6 plus 2 into 1 by 6, so on, plus 6 into 1 by 6. This would come out to be 3.5. So 4 plus 3.5 is 7.5. And so here are the answers for question 2 as well. Again, the 10 marks, I would say pretty straightforward. Many of you might have struggled in part A and subsequently then part B and C. Otherwise, the first three parts of question 2 was pretty direct and straightforward. Question 3, again, a very easy question from Bayes' theorem. We need to calculate the probability that the selected television was made in factory B given that the television selected was defect. So what we want is probability B given DEF. So this is nothing but simply probability defect given made in B into probability made in B divided by probability that it is defect, which can take in three forms, either in A or B or C. So this is again direct by standard formula A2. So the answer would be A2. Putting the values for it, you would basically get 12 by 31. So the ones who were able to attempt part 1, part 2 was nothing but a cakewalk. You simply had to put the values which were already mentioned in the question. Moving forward for the next question, question 4. We have been giving a probability density function a e to the power minus 5y where y is greater than b. A and b are given to be positive constants. Write down the bounds of the integration required to calculate m by t. So what is m by t? Expectation e to the power ty, that is integral of e to the power ty fy dy, and the limits would be nothing but the possible values which y can take. So here y is given to be greater than b, therefore my lower bound will be b and my upper bound will be infinite. Lower bound is b, upper bound is infinite. Next part was to calculate it. So there I have calculated. We need to simply apply normal integration, and I am assuming that t is less than 5 so that this becomes positive and when I put infinite here, I would be getting a term of 0. So this is the answer which I'm getting, that is A4, and the assumption or for which the part 2 result will hold is when t is less than 5. Otherwise, this particular term, if you would carefully see, if t is greater than 5, this becomes negative. Any negative number into minus infinite becomes positive infinite, and e to the power of infinite is nothing but infinite, so basically it would become undefined. So to have a, what to say, a definite answer, what we need is t is less than 5. So first three parts, most of the students I had a talk with, they were able to attempt. Quite a few struggled in part 4. So you need to remember one property, that is my0 is nothing but 1. My0 is nothing but expectation e to the power y into 0, that is expectation e to the power 0. E to the power 0 is 1, so I basically have expectation 1, which is nothing but 1. So using that property, I substituted t as 0, and I know I would be getting the answer 1. Solving it, I basically get a is nothing but 5 e to the power 5p. So part 4 is where few of the students had struggled to get this answer. Moving forward, next question 5. Again, a very direct question. We need to find the values of sxx, syy, sxy. These are direct, straightforward. The formula for these are also given in actual tables. Alternatively, you could have referred to institute material as well. And this is something which we expect that well prepared students will remember by default. So one doesn't necessarily need to refer to the any tables or material, as this would consume some time. But yeah, if you're not sure about it, it's always better to refer to materials wherein the exact formula is given. Part 2 was finding the Pearson's correlation coefficient, and part 3 was estimating A and B. 6 marks, a very direct question. There's the formula of Sxx. It comes out to be 25.9. Next is 16.1, 19.3. R comes out to be 0.945 something. B comes out to be 0.745 something. A comes out to be 2.193 something. So again, a very direct question, pretty scoring one. Moving forward, sixth question, state the three components of a GLM. This was a direct bookwork. You can refer to the institute material. You would be getting the answers for this. Part 2 was state the specific form of each of the three components of the GLM. So here we have been given mx is e to the power a plus bx. Using part 1 itself, you can solve the part 2. So again, part 2 is almost a direct bookwork. Part 3 was identifying the likelihood. So I have a Poisson model. So a Poisson, the probability at a point is nothing but e to the power minus lambda, lambda to the power x by x factorial. In this question, my parameter is e to the power a plus bx, and this point x is nothing but represented by dx, the number of deaths. So the correct option which will give us the right likelihood will be A1. Part 4, we had to calculate the value. There are various ways to do this. I have been given 40, 41, 42, 43. First of all, if you will just put the values of A and B, and if you are able to observe the values, all the terms, e to the power something, e to the power something, that something is coming out to be negative. So e to the power anything negative lies between 0 to 1. So now if I am multiplying numbers and all numbers are less than 1, so the result would also be less than 1. So one way is to eliminate the answer, that is A2 and A4. Then the way I solved this was either it would be A1 or A3. So I didn't try to calculate the exact answer. I tried to calculate the first three terms, and then I was getting an answer which was less than this value. So I knew that the answer had to be 0.0008. So this is how you could have saved time. Typically, we do not get MCQs in these type of papers, so we are not really inclined to work towards it. But the ones who had prepared for MCQ or who have appeared for the competitive exams or Olympiads in school and know how to tackle these MCQ questions, it's always about not solving the entire question but knowing which answer is correct. And you can very well apply method by elimination as well for these type of questions to save your time. Question 7, it's from GLM. Again, a pretty direct question. This is nothing but PDF of a normal distribution. We need to identify the correct form of it. So this was coming out to be nothing but option A2. This is something which, our students, we have already covered this in class, and one can even refer to institute material for this. So question 7.1 part A2. If you have already done this, part 2 we need to identify B theta, A phi and Cx comma phi, and we would be getting this as A4, option A4. Now, moving to the next part, the analyst suggests that expectation X is M and standard deviation is S square. Okay, so this is what it has mentioned. If you would observe the model, I'm getting here S square, so I know that this term is nothing but the variance of the normal distribution. So we need to comment whether the analyst is right about the mean and standard deviation of this distribution. So definitely it's wrong about the standard deviation of the distribution. That is something we know. We need to use the property of exponential family to show how we can infer it. So we know that the mean of an exponential family is b dash theta and the variance is a phi into b double dash theta. B theta is theta square by 2. We differentiate it once, we get theta, and theta is nothing but m. We differentiate it twice, we get 1. A phi is nothing but s square. So variance is coming out to be 1 into s square, which is s square. So the analyst is right about mean, but not, this would be T, not D, about standard deviation. Part 4 is again something which is a direct bookwork. Part 5 EBCT, that too model 1, pretty easy for you all to score on this. So I'll quickly show the values of part 1 ABC, part 2 and part 3 are nothing but asking for assumptions. Again, part 3 is something which is direct bookwork. So if we quickly look forward, part 1, A 39.5, B 46.5, C 276.4167, Z was coming out to be 0.9224138, and the value which we had to estimate is coming out to be 21.51293. So again, this was a very scoring question. In fact, the entire paper, as I've already mentioned earlier, it was a very easy paper. So question 9, Zx 299 Sx square by sigma x square. We have 300 data. This 299 is nothing but 300 minus 1. So this entire term is nothing but n minus 1 s square divided by sigma square, and we know that this follows a chi-square distribution with n minus 1 parameters. So Zx is nothing but chi-square with degrees of freedom as 299. Next part asks us the mean and variance. We know that the mean is the parameter itself and the variance is twice the parameter. Now as n increases, we know that chi-square n tends towards a normal distribution. Here n is 299, which is sufficiently very large, and therefore we can approximate this as a normal distribution. So part 4 Zx approximately follows normal 299, 598. These are the two equations which we will use to calculate the 2.5 and the 97.5th percentile, standardize and solve for it. The answers are coming out to be 251.07. These are up to 2 decimal places I have quoted. You can also mention till as many decimal places as you want. And B is 346.93. Then we have been given data about the mean income, the mean rent, the realized sample deviation and the realized sample deviation of rent and income, both of them. So we need to find a calculator 95% confidence interval for the mean income. As n here is 300, we have the sample standard deviation. We could have used the t distribution, but for large values of n, t distribution again is nothing but my standard normal distribution. So x bar 1 plus 1.96 s by root n, answer will come out 1814.12, 1861.88. Similarly, next part 6 for the rent, 576.88 divided by 639.12. Part 7, we need to basically find for variance. So we already know that we have already calculated the 2.5% quantile and 97.5% quantile. Using this, I can also get the values for the variance. It's coming out to be 38,370. I have rounded off to the nearest integer, and 53,020. Next part, which one of the following gives the correct option? So a plus bxi plus zi, where zi follows normal 0 comma sigma square. This is the normal inference model which we use. Part 9 we need to find. So we know easily that b is nothing but sxy by sxx, and a is nothing but y bar minus bx bar. We have already calculated the required values. So the slope is coming out to be 3.72471, and a is coming out to be minus 6,238.013. Again, the first three parts, or should I say the first four parts, was pretty direct. For some of you might have spent some amount of time in part 5 and 6 thinking how to use the t distribution if you're using it. Alternatively, if you would have realized for large values of for large values of n, my tn basically becomes a normal distribution. Moving to the last question, question 10. So first part is state what is meant by response and explanatory variables in a linear regression. It's a direct bookwork. If you observe the graph, you would see some form of positive correlation. As the values in x are increasing, you would see this value, this value, this value, they are decreasing. Even this value might be. But in general, as the school index increases, the house price index also increases. So we observe some form of positive correlation. You can express this to be weak, or you can also see that there is some form of positive correlation. Part 3 is performing Fisher transformation test. So the answer coming out of the test statistic is 2.295. This is the formula. B we would reject, as critical values are this. We are getting a value which is greater than critical value. Therefore, we reject the test. Part 4. We perform a t-test for the slope parameter, whether it is significantly different from 0 or not. So we have been here giving combinations of sxy, syy, sxy. One way which I applied is 7.386. This is the slope. Slope is nothing but sxy by sxx. So you can just take the value of say sxx, multiply by 7.386. It should match with the corresponding value of sxy. So that's the easier way to solve this question. So the option which only one option fits this, that is A3. This is the technique which I use to solve. For the next part, calculate the value of the test statistic. We have beta hat minus beta by standard error of beta. This was coming out to be 2.798. The distribution which I use is nothing but Tn minus 2, and we would be rejecting as this is coming out to be greater than the critical values. So hope that you all found this video useful. Tomorrow around evening, we shall be sharing the video for CS1 paper B as well. Don't forget to like this video if you found it useful, and don't forget to subscribe to our YouTube channel. Have a good day, guys.